Today we'll be talking about the order of operations. Most AV math only requires you to add, subtract, multiply, or divide. We call these operators. But every so often, equations get more complicated like this one. Fortunately, the order of operations gives us a method for tackling more complex formulas. Understanding the order of operations is essential in the AV industry because it ensures that calculations are performed accurately, whether you're designing a sound system, calibrating equipment, or setting up a lighting grid. The order of operations helps prioritize what parts of the equations to tackle first, second, third, and fourth, like prioritizing tasks on a to-do list. Let's break down the rules. First, tackle any numbers that are within parentheses or brackets. Next, handle any exponents, which are also known as indices or orders. Be sure to take care of any logarithmic or square root parts at this step as well. Following that, tackle any multiplication or division operations. Remember to handle juxtaposition, which means treating numbers that are placed next to each other as being multiplied, such as 3 parentheses 36 being interpreted as 3 times 36. The final step in the process is to perform any addition or subtraction. What if you encounter several operators at the same level? In this example, we have multiplication, division, addition, and subtraction. When the operators are on the same level, we work from left to right. Begin with 3 times 4, then 10 divided by 5. Next go 12 minus 5, then 7 plus 3, and finally 10 minus 2. A mnemonic you can use to remember the order of operations is "Please excuse my dear Aunt Sally," or the acronym PEMDAS. Depending on where you are and what terminology your region uses, PEMDAS, BIDMAS, or BODMAS might make more sense. Let's look at this slightly more complex equation. First off, notice there are no parentheses, so we skip ahead to exponents. We'll tackle 2 squared first. Calculating 2 to the power of 2 gives us 4. The next step is to handle any multiplication or division. We see a division here, 20 divided by 4. When we do this division, we get 5. We now have 5 plus 4. The last step is doing the addition. Adding 5 and 4 together gives us 9. What if we add parentheses somewhere to this example? When there are multiple operators within parentheses, follow the PEMDAS steps within the parentheses first. For example, within the parentheses, we have both addition and an exponent. According to our rules, exponents come before addition. So we calculate 2 squared, which gives us 4. Our equation now simplifies to 20 divided by 4 plus 4. Still working within the parentheses, we add 4 and 4 together to get 8. The equation now simplifies to 20 divided by 8. Finally, we perform the division operation, dividing 20 by 8. This gives us a result of 2.5. Rounding is another key consideration in the order of operations, particularly when dealing with complex problems. Let's look at the following example. When rounding, identify the place value you will need to round to, in this case the tens place. Look one place to the right. If the digit is 5 or greater, you will round up. If the digit is 4 or less, you will round down. Since the digit to the right is 0, the 2 in the tens place will remain the same, meaning the number is closer to 1 and 2 tenths than 1 and 3 tenths. In this example, we will need to round to the nearest whole number. In this case, the digit 6 in the ones place. Looking to the right, there is an 8. Since 8 is greater than 5, the 6 will round up to 7. Let's work through an AV math example about loudspeakers that you might come across. A conference room is 40 feet by 30 feet, and the ceiling is 10 feet high. Ceiling loudspeakers will be used to cover the room for speech reinforcement. The loudspeakers have a coverage circle diameter of 12 feet. Using partial coverage, how many loudspeakers will we need for this room? To calculate partial overlap loudspeaker coverage, we use this formula. To determine the number of loudspeakers needed, calculate the required loudspeakers for the length of the room and round to the nearest whole number, then do the same for the width of the room. Finally, multiply the 2 rounded numbers to get the total. Starting with the length, we will first find the square root of 2. Divide 12 by 2, then multiply by 1.414. Next, we will divide 40 by that answer. Finally, the 7 in the tenths place tells us to round our answer up to 5. Now calculate the width. We will first find the square root of 2. Divide 12 by 2, then multiply by 1.414. Next, we will divide 30 by that answer. Finally, the 5 in the tens place tells us to round our answer up to 4. To find the total, we would multiply the length by the width, getting 20 loudspeakers needed.